Good day. For those of you who do not know me, my name is Douglas Harder, and in this topic we're going to describe complex finite dimensional vectors. So in this topic we will describe complex n-dimensional vectors. We will introduce the notation of c to the n. We will describe the zero vector and the concept of equality for complex vectors. And we will discuss comparing vectors of different dimensions. And the spoilers just don't. So, if n is a positive integer, a complex n-dimensional vector is a sequence of n complex numbers written as follows, where each entry u sub 1 through u sub n are complex numbers. Now it's important here, as with real vectors, that these are ordered. So you cannot just arbitrarily reorder the entries. The first entry is the first entry of this vector, as is the kth entry, as is the last. Now, we will represent all n-dimensional complex vectors by a capital C with a superscript n. You can read this as u is an element of c to the n, where again the symbol between the vector and c to the n is the operation of saying that u is a member of or an element of the set of complex vectors of dimension n. So, for example, this first vector here is in c to the 5, and the second vector is a complex 8-dimensional vector. Now, the zero vector in c to the n is still represented with a boldface 0 and a subscript n, and it is the vector containing n zeros. However, in this case, it's technically 0 plus 0j. Two complex vectors are equal if and only if each of their n entries are equal. Again, we are not going to ever be comparing real n-dimensional vectors with complex n-dimensional vectors. Either we are modeling something with real vectors or with complex vectors, but there's not much point in comparing the two. So we're either working with real vectors or complex vectors. There happen to be complex n-dimensional vectors, each of which has a zero imaginary component, but again, it really doesn't matter much. We could say that there are real n-dimensional vectors that correspond to some complex n-dimensional vectors, but again, this is apples and oranges. So, following this topic, you know that there are n-dimensional complex vectors that have n complex values. You know that the set of all n-dimensional vectors is represented as capital C boldfaced to the power n. And you understand that if v is a vector, its entries are again v1 through vn. You are aware that the zero vector is again the same as before, and a vector with all zeros. And you understand the idea of equality between n-dimensional complex vectors. All entries must be the same. And again, you are aware that we do not compare real and complex vectors. Here's the references, acknowledgments, the colophon, and a disclaimer. Cheers!